Hey, it's Casey here. For this Engineers Day post, I decided to do a little bit more video since it seems to be a better way to explain things. This week, we tried to test this turbine. This is a Tierney TT10 turbine that I acquired on eBay a few years ago. And ever since then, I have been trying to get this thing running. So today, since we've been having problems with getting it to light on kerosene, I decided to adapt the turbine to run on propane and see if it actually fires up today. So I want to show you just kind of what I have going on here on this side of the turbine for now. So obviously right here, this is the Tierney TT10 turbine. I've built a little steel structure surrounding it to kind of house all of the little components, bits and pieces that are required to actually make this run. This is the inlet. So all these little holes right here, air comes in here, gets set on fire here, and then this is the business end of the turbine. To kind of run it, a few things that are necessary. This right here is a variable reluctance speed sensor. So right here is where it picks up the turbine speed with a little transformer. Up here we have an oil pressure switch. Since the bearing relies heavily on oil, this pressure switch tells me that there's oil actually flowing through that bearing, which is very important when this engine is spinning at about 50,000 RPMs. To start the engine, we have right here a nice spark plug. So this is it's very loud and it's very scary, but I don't know exactly the power output. I've been told it's about a 1 to 2 joule spark plug, but this is standard for most jet aircraft. So this is actually a similar plug that you'll find in the commercial airliners that you fly across the country in. And then on the back of the turbine, there's a little temperature sensor. This measures the exhaust output. And this is very important for keeping the turbine from melting down. Obviously you don't want, when you see fire coming out the back of an engine, it looks cool, but what that's actually doing is that's burning everything inside. So I use this to measure the output temperature, make sure we're within the normal ranges. As you can see, the orange line here, this is for bringing the propane in. Originally, this is set up to run on kerosene or Jet A, which are very, very similar fuels. And so the first stage obviously is fuel in. So this is a fuel filter. So this filters out all the little particulate, because obviously you don't want junk and debris going through this nice high precision machine. And then here is the fuel pump. So the fuel pump draws the fuel through the filter into the pump and then out towards the engine. This fuel pump is pretty standard for aircraft. And it runs much like a hydraulic pump would. So the fuel pressure here is, I want to say it's between 60 and 80 PSI, which is pretty high when you're thinking about running kerosene. And then finally here, which this is what I think is broken. This is a fuel cutoff switch. This is actually wired into the control loop that if I ever hit the e-stop button, what it does is it shuts fuel off to the engine and purges the rest of it overboard. And I think that this has been my problem with trying to light it on kerosene. And so this is what I'm going to be working on for the next few months to figure out if I can replace it or fix it. Finally, assuming that all this works, fuel will go through this line, and there are actually 3 injectors on the backside of the engine. And so it just pumps fuel through there and tries to burn it as fast as possible. So obviously up here, this is the starter for it. This thing is huge. So the starter solenoid, much like in an automobile, so this pulls back, locks the solenoid, and the starter starts turning the engine. There's a nice big gearbox on here that is a 4-to-1 reduction. So it takes that 48,000 RPMs and brings it down to a nice and easy 12,000 RPMs, which is still incredibly unusable. So the shaft here is designed to actually run a generator. And in its previous life, it was a generator for a flight line in the Navy somewhere. So that's at least the NATO tags that are on this. You have all that oil that's running through this machine. You got to cool it, so we have an oil cooler. And then this is just a standard filter. Great thing about military stuff is they try to use very standard parts. So this is just a filter I picked up at the auto parts store, and it just keeps particulate out of the oil. before it goes through the bearings. And then finally, this is kind of the part that I've been working on for the last few weeks. This is the control box, and it's actually running one of our Pro Minis, and I have a few of our MOSFETs to control the fuel pump and the fuel switch, and then our Beefcake relays are actually controlling the spark and the starter and the oil cooler. I got a little bit more work to do. You know, I still have some wires to hook up and more tweaking, but I think we've made some pretty good progress. So until next time, thanks.